Okay, linear modeling, page 6. In the book, they explain what the least squares regression line is. The least squares regression line is very similar to a best fit line. The difference is a best fit line we did when we didn't have computers and we eyeballed it with a pencil and a ruler. A least squares regression line takes advantage of computers and it optimizes the line. It does what we tried to do with our eyeball, but it does it in a quantitative or numerical way. What it does is it imagines a line going through a cloud of points, and then it says, okay, what's the distance, the vertical distance between the line and each one of the points in the cloud? And it makes an expression. It squares each of the distances. The main reason why it squares it is because squaring it makes everything positive. So then negatives and positive numbers don't cancel each other out, right? So then they square it, which makes the distance for everybody positive. And then it adds them all together. So you can see that if the line was really far off, like down here, you can see that all the distances would be very big, and then your distance expression would be bigger. So how do you make this as small as possible? Well, you try to put the line right through the middle of the points, and that will minimize the distance between the line and each one of the points. So what we're trying to do is we're trying to minimize this expression. All the vertical distances squared and added together. We're trying to minimize that. Okay. And it turns out that when you try to minimize this, you get the least squares line. Okay. And the calculation to find the least squares slope and the least squares line y-intercept is not a complicated calculation. It's very similar to the calculation we did to find the R value. So it is possible to do it by hand or with a spreadsheet. And if you do this in your internal assessment, you would do it manually, showing all the steps. Okay, but the calculator does it very easily using the same command that we use to find the R value with the calculator. We use Lin Reg, and that gives us the equation for the line. So the first problem on this page tells us to use the data sets in the last page, in question 1, to find some Lin Reg equations, regression line equations. And so we'll do B. Okay, so let's see. First thing we're going to do is we're going to type the data in here, which is much better than doing it by hand, but still not so fun. So I'm going to do the first couple here. We're going to put 13, 18, 7. And I'm not going to make you watch me do all the others, but in the second column I'm going to put 10, 6, 17, etc. Okay? So hold on a second, I'm going to do that and I'll come back. Okay, so I put in the B data here in list 1 and list 2, and now I'm going to go back to this page and I'm going to find the Lin Reg equation. So I do stat calc, go down to Lin Reg, I hit enter, and I put list 1 and list 2 in for the lists for x and y, and then I do a calculate. And so my equation is going to be, for B, it's going to be y equals negative 0.707x plus 18.6. Okay, and the R value here, just in case we want it, which they don't ask for it, is negative 0.915. Okay, so you can see how to do each one. You just put everything into the stat edit page, and then you run Lin Reg, and that'll give you the equation in gradient intercept form. Very easy, right? Number 3. Steve wanted to see whether there's any relationship between the temperature when he leaves for work in the morning and the time it takes to get to work. So he's thinking that if it's cold or hot, then it's going to make it take longer to get to work. I don't know exactly why. Maybe the car doesn't run as well when it's hot or cold. Okay, so he collected this data, And then we're going to do a scatter diagram of this data. So let's see, what's the largest number in the x's? I'd say the largest number in the x's looks like it's 35. And the smallest number is 16 maybe. And for y, the largest number appears to be about 49, and the smallest number appears to be 31. Okay. So now let's looks like the data kind of ranges up to let's see, 35 in the 5, 10 in the x case, 15, 20, 25, 30, 35. And in the y case, looks like it ranges up to 50. So I'll do 50, 40, 30, 20, 10, 0. Okay. So this is temperature and this is time. And so first we're going to do a scatter diagram. 25, 35 would be there. 19, 42, about there. 23, 49, about there. 27, 31, about there. 32, 37, there. 35, 33, there. 29, 31, there. 27, 47, there. 21, 42, there. 18, 36, there. 16, 45, there. 17, 33, there. 28, 48, there. And 34, 39, there. Okay, that's kind of a fat cloud. So we drew the scatter diagram, then it asks us to calculate R. To calculate R, of course, we do need to do stat edit. And I'm going to show you how to put stat edit in L3 and L4. And we're always using L1 and L2. Let's use L3 and L4. Okay, that way we don't have to overwrite the data that we put in there. So I start myself off by putting 25, 19, 23, and so on, right? And I'm going to do this offline, but I'm just going to put this in the L3 column, and I'm going to put this in the L4 column. I'll be back in a sec. Okay, I just put in my data, and I'm going to do a stat calc lin reg so that I can find out my R. And since I use L3 and L4, I need to put in second 3 for L3, and I need to put second 4 for L4. Second 4 for L4, and then I go down to calculate, and then it gives me for R a negative 0.219. And then it asks me if to describe the relationship between the variables, and first of all, it's a linear correlation that's negative. And looks weak because 0.219 is very close to 0. Let's check out in the previous page what 0.219 would correspond to. It would correspond to weak because it's between negative 0.5 and negative 0.01, negative 0.1. So I would say it's weak. We'll go back here. And we'll say it is negative weak. Is it reasonable to try to find a line of best fit for this data? Explain your answer. Well, I would feel better about it if the R value was closer to 1, because if it's close to 1, that means that yes, you can describe this data with a line. Now, do you see how this data looks like a kind of a cloud? A real cloud. It's like a cloud that's, a big blob. So, it's kind of hard to say that this is a line. So Maybe no, because the correlation, the linear correlation, is weak. Okay, so not so reasonable maybe. Okay? And that's it for page 6.